Hey everyone, so we are solving rotting oranges question this time, and we are solving this using BFS. So this is an example we are using to understand what the question is trying to say, and we'll use this example to actually walk through how we are going to solve it so that you understand the intuition nicely. So we are given this array which can consist of n number of rows and m number of columns. So we would have a fresh orange which would be denoted by 1. We would have a rotten orange which would be denoted by 2, and we would have empty cells. So the question says orange, but we've used fruit here just for understanding purpose. You can take any fruit for that matter. So the thing is, this red fruit basically indicates that this fruit is rotten. These yellow lemons basically are fresh fruits, and then there are empty cells. The question says that a rotten orange or a rotten fruit can 4-directionally rot another fruit, fresh fruit, in 1 minute. So find out how much time will elapse until we have no fresh fruits. So that's the question. So at minute 0, this is how our matrix looks like. Here we have a rotten fruit and we have 6 fresh fruits. So a rotten fruit can actually 4-directionally rot other fresh fruits. So what's the 4 direction of this? It will go up, left, right and down, right? Up and left. Those are not valid indices. So it will go right, and it can go down and rot the 2 lemons there. So at minute 1, these 2 lemons also have been rotten, and we have 3 rotten fruits as of now, and we have 4 fresh fruits remaining. Now this rotten lemon at index 00 has rotten the other 2 lemons. Now we have this lemon. This can go 4-directionally and rot fresh fruits. So what's the 4 direction? It will go up, but that's not a valid index, so no rotting there. It can go left, but that's already rotten. It can go down, so it will rot this lemon, and it can also go right, so it will also rot this lemon. Same here as well. For this, it can go this side and this can go this side, so this lemon will get rotten. It can go down, but here there's an empty cell. It can go left, but that's not a valid index, and if it goes up, that was already rotten. So what happens when minute equal to 2? We have 5 rotten fruits and we have 2 fresh fruits left. Now this new rotten fruit, can it rot any more fresh fruits? No, because up and right are not valid indexes. Left was already rotten and down is an empty cell. Now what about this? It was rotten. So what about this newly rotten fruit? Now this can go down and rot this fruit, right? The other indexes are not valid. I mean, up and left were already rotten and right is an empty cell. So what happens when minute is equal to 3? We have 6 rotten fruits and we have 1 fresh fruit left. Now this newly rotten fruit, it will rot this fresh fruit at minute equal to 4. And now we have no fresh fruit left. So minute 4 is when all the fresh fruits have rotten, and that is when we will exit from the loop. and our answer would be 4. To understand the edge cases better, we have another example which will help us understand some edge cases to solve this LeetCode question better. So in this example, we've taken strawberry, and this is a rotten strawberry, FYI. Now, here we see we have no fresh fruits, and we have one rotten fruit. So at minute 0 only, we have no fresh fruits, which means we have to return 0 the same minute. No calculations required. Since there are no fresh fruits, there is nothing this rotten fruit would be able to affect, right? Okay. Another example that we've taken to understand the test cases, the edge ones better. So this is 1 cross 1 2D matrix, 1 cross 1 matrix. So it's a 1D matrix. And we have a fresh fruit here. This is an apple. And we have no rotten fruit. Now, since there are no rotten fruits, there is no way, or we can say it is kind of not possible, that this fruit will get rotten. So that's why we are returning -1 here in this case. Now we'll walk through the code. Here we have created a class called index, which would have row and column as its field, and we've provided a constructor. Now, in the function oranges rotten, we have this grid which is passed to us as a parameter, which is like a 2D grid. So firstly, we count the number of fresh fruits and we count the number of rotten fruits. So we initialize it to 0, and here we check if the value at grid ij equal to 1, our fresh count will increase, else rotten count will increase. And I'll come to what we've done at line 26 later, just in a while. And we'll quickly move to code number line 31, which says if fresh count is 0, we're going to return 0, because that is the minute where there's no fresh fruit left, right? Now what happens if our rotten count is 0? We return -1, because the thing is there's no way other fresh fruits could get rotten, right? Okay. Now what happens if these two cases are not? I mean, we have fresh fruits and we have rotten fruits. What do we do next? So then, all the fruits that are rotten need to be added in the queue initially. So that's why we have added, so this is like we have queue of index type. So we've added these indexes where there are rotten fruits. Now what we do is, until queue is empty, we are going to run this while loop. Now in this while loop, we have initialized minutes to 0. Okay. Now I'll come to what this while loop does. But let's see, return fresh count equal to 0. If yes, it will return minutes, else it will return -1. The question says that no fresh fruit should be left. So that's why we are checking if fresh fruit count is 0. If yes, we are going to return the number of minutes in which all of the fresh fruits were rotten. Else, if there are fresh fruits remaining, even after this while loop ends, we are going to return -1. Now what we have done in the while loop, coming to the while loop, now what we're doing is we're calculating the size of the queue, because that is the number of oranges or the number of fruits that are rotten right now at this present minute. Let's say at minute 0, what's the size of, or what's the number of fruits rotten currently, like at this particular minute. So that's the size. And for that number of elements, like from I to 0 till I less than size, we are going to run this for loop. Now we also have a flag boolean variable, which we'll come to later. What's the purpose of this? But let's start with this for loop. So what are we going to do is we are going to poll from the queue. And let's say I poll from the queue and I get a current row index and a current column index. So now I'll see if that current index could rot other fresh fruits 4 directionally. That's why we have dx equal to 0, 0, 1 and minus 1, and then same for dy, so that we can go 4 directionally combined. So what happens is we'll run this in a inner loop for like 4 times, which would be checking 4 directionally if we can rot other fresh fruits. So this is the new calculated row index, which is current dot row plus dx of j. Same for we have calculated the new column index. And then what we are going to do is we have to check if nr and ny are valid indices. If yes, and also if it has a fresh fruit, if the value is 1 at grid of nr and ny, then what we are going to do is we are going to decrement the fresh count. Very important here. We'll come to the flag part just in a while. And then we're going to rot this orange. So that's why we have done grid of nr and y equal to 2. That is important so that it also helps us prevent duplication and visiting the visited node again. So it prevents us from visiting a visited node again, visited index. So then what we do is, if it's a valid index and if it's rotten, it will rot more oranges. So that's why we add it to the queue. Now we do this, and let's say and then coming out of the loop, we do minutes plus plus. That means at this minute, whatever fruits were to be rotten, it is rotten, and that's why we increment the minute, because that is where in 1 minute time it will rot 4 directionally. So we increment minutes here. Now let's see what happens with the flag thing. Now let's say we are doing this, but at any moment there are no more at, let's say, any level or any iteration, there was an iteration where no fresh fruits were rotten by other rotten fruits. Let's say this was never done. I mean, no rotten fruit actually forwarded or did rot in any other fresh fruit. That is where we know that there is no use rerunning this loop, right? So that's why we have a boolean flag here, which we initialize to false before this inner for loop, this I loop. So, and if at least one fruit is rotten, we make flag equal to true. And after coming out of this for loop, we check if flag is still false. It means we need to just break and come out. There's no use going ahead, because none of the other fruits were rotted, so that's not propagating. So this is the use of flag here. And we've also checked if fresh count at any point becomes equal to 0. Even then we don't need to we don't need to proceed any further, right? We don't need to check any other thing, because at that particular point we got fresh count equal to 0, and that's why we break this loop and come out of the loop. And then if fresh count is 0, return the value of minutes, else return -1. That is what the question asked us to do. And this is the code from my end. I hope I was able to explain this concept really good. This is a very famous question on BFS. So that was it from my end. Thank you.